Exercise 14.5. For questions 1 to 3, show your answers on a grid with x and y axes running from -3 till 4. Okay, so we would be given with the grid like this, as it has been told that x and y axes both run from -3 till 4. So we can consider it like -1, -2, -3, then 1, 2, 3, and 4. Same goes for the y x-axis, 1, 2, 3, 4, -1, -2, -3, and -4, though it is not required, so let me not consider it. Okay, now by shading the unwanted region, the region that we do not require, show that the region that represents the inequality, this one. Okay, first of all, we need to see what is the associated equation. Equation is going to be, we just need to replace the inequality sign with an equality sign. So this is the associated equation given the inequality. Now we need to have some values for x and y so that we can plot the graph. And since we know that to draw the graph of an equation, minimum 2 points are sufficient. So let me draw the table of the values x and y. If we replace x0 here, this would vanish. So 2y equals to 6. That would give us 6 by 2, that is 3. The value of y would become 3. And this is actually known as the y-intercept. Y-intercept means the point where the graph of this equation would intersect or cut the y-axis. Then if I replace y equals to 0, let's suppose this term would vanish when I will replace y is equal to 0. So I'm left with -3x is equal to 6. So 6 divided by -3, that will give us -2. So now these are the points we need to plot on the graph. x0, y3. So this is the y-intercept. And then x -2, y0. This is the x-intercept. So when we would be drawing its graph, it is going to be a line like this. Okay. One thing that is to be mentioned here is that this inequality is a closed inequality containing greater than or equal to. So that's why we have made the line as a solid line. Had it been an open inequality like greater than or lesser than, then this line would have been a dotted line, like it would have been like this, a dotted line like this. Okay, so this is the difference between the closed inequality and an open inequality. So let me revert it back. Yes, because in this case we are given with a closed inequality greater than or equal to. Okay, now we need to see one thing, that we need to shade the unwanted region. What is the region that we want? We want actually this expression should be greater than or equal to 6. So this is the region that is lying above the line that we want. So this is the wanted region above that, and this is the unwanted region below that line. So since we need to shade the unwanted region, so we would just be shading this portion like this. And at the end, let me write down um, the inequality for our wanted region, that is 2y minus 3x greater than or equal to 6. So all this region is our wanted region, which in this condition given in the question, we need to let it unshaded. So the portion below that line has been shaded and the portion above that has been left unshaded. So that completes the question and its solution. Now it's question number 2. By shading the unwanted region, show the region that represents the inequality, this one. Okay. One thing, I haven't erased the previous question so that I can uh, clarify this by the comparison of the two questions. In this case, we are having an open inequality. So the line, wherever would it be, it is going to be a dotted line like this, not the solid line as was the case in the previous question. Okay, so let me wind it off and let me have the same axis on which I need to draw the graph. Okay, okay. As far as the points are concerned, let me just jot them down once again, and that's it. Okay, here would be 3 and so on. Now, again, what I need to do, I need to carry on the same type of working. That is the associated equation is going to be x plus 2y equals to 4. So the only thing that we have done is the changing of the inequality into an equation sign. Okay, once we are done with this, now we need to have the table of values as we had previously. Let me do it over here as well. This is I'm doing for question number 2. This was for question number 1. The easiest points are if I replace x equal to 0, here this would vanish. So 2y equals to 4, that would give me y equals to 4 by 2, that is 2. And as you know that this is the y-intercept. And then if I, let's suppose, replace y equals to 0, so x would be equals to 4. So this is the x-intercept. Okay. Now let me jot down these points. x0, y2. This is the point, the first point. And then x4, y0. This is it. Now we need to draw its graph, and it is going to be like this, passing from here. But in this case, the line would not be a solid line, rather it would be a broken line. So let me redraw it like this. It has been drawn a bit tilted, but the concept is clear. Okay. Now I just need to see for the region which it represents. Since it represents now less than 4, that is the region we are interested in. So less than 4 means the portion below that line. Now this is our wanted region. Wanted, or the required region. And the portion above this line is our unwanted region. So according to the statement of the question, we need to shade the unwanted region. So we would be shading the portion that is above this line. So this portion would be shaded, and the portion below this line would be left unshaded. So this is how this question is to be solved. And at the end, we just need to represent our wanted region by the inequality we were given with x plus 2y less than 4. Means this region is represented by all of these three portions of the three quadrants. So this is our wanted region, this is wanted region, this is the wanted region. So all this region is the wanted region that is occurring below this line. So that's what we have done. Writing it only once is sufficient. So this is how we need to solve this question, and this is the solution to this question. Okay. In the same way, exactly in the same way, we need to do its question number 3. Okay. I haven't erased the associated equation part and the table so that you can um compare these solutions as well. Okay. Now, in this case, again, I need to have the associated equation like this: x minus y equals to 0. Now, in this case, the equation would become even more easy if I write it down x equals to y. And this will give me an easy insight to draw the table of the values as well. Whatever the value of x I'm going to have, in this case, the y has to have the same value. So let me just take one value of the x to be negative. Let it be -2. The value of y is going to be -2 as well. Because of this equation, the defining equation is x equals to y. And then let me have a positive value of x, let it be 3. Then the value of y is going to be 3 as well. Okay. Now, unlike the previous two cases in which we were taking or considering the intercepts, we haven't taken the intercepts in this case. Reason being, if for example, I would have taken x0, then obviously y would be 0 as well. And if I consider y0, again the x is going to be 0. So I would be having only this one point. So uh, the drawing of the graph would have been not possible. So we have changed the points in this case, and then let me now draw them. In this case, the points are -2 and -2, then 3 and 3. Now joining these points, again, in this case, this is a closed inequality. So what I need to do, the line that I need to draw has to be a solid line. Like this. So let me have this point to be marked correctly, which would mean here. Okay. Now this is the graph of the given inequality. And now we need to have the shading of the unwanted region. Now you see, we are having the inequality that is greater than or equal to. So the region after this line, this one is the region that we require, that we want. So this is the wanted region. So according to the condition of the question, we need to shade the unwanted region. So the shading would be this one, this one, this one, this one, because this is the region which is not required to us, unwanted. So this is our wanted region, and this is the region that is representing this inequality, x minus y greater than or equal to 0. So that completes question number 3 as well. This is our wanted region represented by this inequality. Now it will be question number 4. Let me erase the previous working. Shade the region that represents each inequality. This one. Okay. Now let me draw the lines to be. This is the y-axis, this is the x-axis, and I would label them as per my requirement now. So let me solve it out. First of all, I would be changing it to the associated equation, which is going to be y equals to 3 minus 3x. Then I would construct the table of the values xy. When I replace x0, the value of y is going to be 3. And when I replace y equals to 0, it would be 0 plus 3x is equal to 3. And the value of x will be 3 by 3, that is 1. So this is how it is to be calculated. Then I've got these 2 points. I need to jot them down on the graph. So this is -1, -2. In this case, I do not need to have the negative values of x. And for y, 1, 2, 3. The points are x0, y3. This is the one point, first point, and then x1, y0. This is it. So this is the x-intercept, and this is the y-intercept. Okay. Now I need to draw a line using these 2 points, and these are the 2 points. So I need to draw the line through them. But since this is only the open inequality, so the line would not be the solid line, rather it would be a broken line. So let me draw the broken line like this. Okay, let it be like that. Okay. Then I need to have the representation of the line to be y greater than this value. So I need to have the shading of the required region this time. So this is the region that is lying above this line. So y greater than 3 minus 3x is this region. So I need to shade this one. So this completes this question. Okay. Then for part B, the associated equation is going to be 3x minus 2y equals to 6. Then I need to have the table of the values, um, x and y. If I replace x equals to 0, the value of y is going to be 6 by negative 2, that is negative 3. And if I replace y equals to 0, the value of x is going to be 6 by 3, that is 2. Now replacing or jotting these values on the graph, it would be x0, y negative 3. So y negative 3 is where? It would be negative 1, negative 2, negative 3 here. Then x2, y0. For that, let me erase the previous work. Okay. This point is here, x2 and y0. And then I need to draw the graph. Now, since the inequality is a closed inequality containing equal to sign as well, like this one. So the line has to be a solid line. That means it would be this line. And since I need to have the region greater than 6, so the portion that represents greater than the given line is the one which is lying after that, means this one. So this is the required region, which is represented by 3x minus 2y greater than or equal to 6. So all this region has to be shaded just like this. So that was part B. Part C and D are very simple. For part C, x should be lesser than or equal to 5. So where would be 5? Let me erase the previous work. Now I'm directly doing part C. That is okay. I'm just winding it up. 3, 4, 5. Drawing it like this. X equals to 5 is this line. And since I need to have less than or equal to this value of x, so my required region would be all this region before this line, this one. This one is the required region, which is representing x less than or equal to 5. So this is it for part C. And similarly for part D now, it is just a matter of 1 minute. Y equals to 3 is this line. And I need to have the value of y greater than this, greater than 3. So the region above this is going to be my solution. But before that, I need to see that